Welcome to Open Source Options. This tutorial will show you how to calculate land surface temperature from Landsat 9 data. Now, this workflow is much simpler than it used to be. We can now use collection to level 2 data, where we just have to convert from digital number instead of working from the collection to level 1 data, which required additional calculations to get to surface temperature. So it's going to be easy. Let's go through and show you how it's done. The first thing to do is to find a location of interest. I'm going to zoom in on an area where we should see some good definition in land surface temperatures. We have a valley over here. If we can find some water in there, that will give us oh, good. That will give us a good definition between the mountains, the valleys, and the water. We have forested and unforested areas. Let's go here and give this a try. I'm going to click Use Map to select these coordinates to search this location. Oh, by the way, I'm on earthexplorer.usgs.gov to download the Landsat data. I have a full video tutorial on how to do this if you're unfamiliar with it. Now I'm going to enter some search dates. So we'll go from about July 21st until August 11th. And then we'll go over to our search results. And I should note that on my data sets here, I have a Landsat collection 2 level 2 selected and the Landsat 8 to 9 OLI tiers data set. Now if we go to our results here, you can see we have several images. Let's go ahead and see what these look like in the overlay. So if I show the browse overlay, it will show me the image. Okay, that's not quite the area I was looking for. Let's try this one here. That's the one I want. That's overlapping down further south. Let's give that one a try. I'm going to click on the download options here. And then I'm going to click on the product options here. And it gives me the option to download this entire product bundle. So I'm going to click that. This will take just a minute to download. You can see I already have mine downloaded here. I downloaded this in preparation. So I'm going to click cancel, you download, and we'll just start working with the data I already have. So now I'm going to go into QGIS. I'm going to go into my browser, and I'm going to go find that file I downloaded. For me, I have it in this Landsat L2 folder, and it is this image here. It starts with the 038033. I'm going to open that image up and I'm going to come down and do a couple of things. So first I'm going to add in band 10. Notice how it says ST in front of band 10. That is the surface temperature. Then I'm going to come down and grab bands 1 through 7 and add those in. And we're going to create a virtual raster with these so we can visualize everything. So let's go ahead and go to raster, miscellaneous, build virtual raster, select the inputs. I'm going to select 1 through 7, click select all, remove band 10, say OK, place each input file into a separate band. I'll save this to a temporary file for now. We're not going to need this later, and click run. And now I'm going to say close. Now, the next thing I'm going to do is I'm going to limit this to just a small area. I don't need to calculate this for everywhere, but I do want to calculate it for a small area. And I'm going to use my virtual raster to find that area that's going to work best. I want to find an area that's going to have some land surface temperature variation to make it easier to see these changes. So let's change this to bands 432 so we get a true color image. There's our true color. And now we can zoom in to see if we can find an area where there should be some variation in our temperatures. This looks like a good spot here. We can see we have a reservoir or a lake up here. We have some higher mountains, some lower valleys, and some more water over in this area. So if we focus on this location, we should see some temperature variation. I'm now going to clip this image down to that area so we're not calculating on such a large area. So to do that, let's go to raster. Let's go to extraction, clip raster by extent. Now, I have a full video on how to do this also. If you're interested in that, I'm going to work through it quickly here. So we can drop this down. I'm going to draw on the map canvas. Excuse me. I'm just going to draw a rectangle so that it encompasses some of these areas here. Something like this. That gives me the extent. And now I can come down. We will save this as a temporary layer. And I want to make sure I have the correct clipping layer selected. I want to clip layer band 10 here. And let's click, well, let's click run. There we go, let's click run. And now we can close this. So you can see we have band 10 clipped to this location. Now the next step, the next thing we need to do is we need to find our conversion to convert band 10 from its digital number into an actual temperature, which we can do as degrees Kelvin, degrees Celsius, or degrees Fahrenheit. Let me show you how to do that. So we can come over to the internet here and let's do Landsat level 2 temperature if we search for that. And we can come to the USGS documentation here, and this will give us some additional insight into how to do this. So here's the documentation for this band. Notice here it gives us the scaling factor. So to interpret this, we need the digital number, which is the value in our raster band, multiplied by this constant with this added constant here. This is really easy to do. So let's go back to QGIS and perform a raster calculation to get this done. So now we'll go to raster calculator, pull that over here. We want our clipped band 10 to start out with. So I'm going to close this up here inside of parentheses. We're going to multiply it by a constant and we're going to add 149 to it. So let's go grab that constant so we can make sure we get this correct. And it's going to be here. So it's 0.00341802. Probably do this in 2 tries, but we'll get it. 0034. And then let's go get the rest of that number here. And it is 1802. Now when we multiply this, this will give us our value in Kelvin. So let's save this, and we already have a test file in here, but we'll call it our surface temperature in Kelvin. So we can save that. We'll overwrite it. I'm going to click OK to run this. You can see it's completed. So our values range from 295 Kelvin to 333 Kelvin. We can change this symbology so that we have lower values occurring in blue and higher values in red. And you can see there that we easily can see the low temperatures occur over water as they should, and in the mountains as they should. And our higher temperatures, if we switch back to our virtual color raster, these high values are occurring on these slopes without vegetation. We can also see these agricultural fields have low values. Now, let me show you how we can convert this into degrees Celsius or degrees Fahrenheit, which is something you might be more familiar with. So to do this, we just need to do another raster calculator calculation. And we're just going to take our degrees Kelvin and we'll go find the correct conversion so that I get it right. But I believe if we're going to Fahrenheit, we'll do minus 273.15 Kelvin, multiply by 9/5, and add 32. So this should give it to us in Fahrenheit. If we wanted it in Celsius, we should just have to subtract this 273.15. But let's just check that conversion on the internet real quick. So let's go convert Kelvin to Fahrenheit. And you can see here we have our Kelvin minus 273.15, that exact same equation. If we change this to Celsius, then It is indeed, we just subtract 273.15. So with those, we can run this calculation. Let's save this to a file. And you'll see that I've already have this one here. We'll save it to Fahrenheit. So let's save that. Let's replace it. Let's say OK. That's going to run. And we can now change this to single band pseudocolor with that same symbology. You can see that our values range from 71 degrees Fahrenheit to 141 degrees Fahrenheit, and those seem to fall in an acceptable range for Fahrenheit values. If you're in a country where Celsius is your standard temperature units, then you can go do this in Celsius. But that's how you can very easily calculate surface temperature in QGIS from Landsat data. I hope you found this useful. If you like this tutorial, check out my channel for other tutorials and check out opensourceoptions.com, where I'm going to be having some free online courses for GIS and remote sensing. I've started the first one already. Once that's done, there are more coming. Thanks for watching.